Today we'll be determining if the following series is absolutely or conditionally convergent, and it's this alternating series of from 1 to infinity of 1 over the square root of n. And to start off, we have to make sure that this series converges or not. So we could apply the alternating series test. So we could take the limit as n approaches infinity of 1 over the square root of n, and that clearly goes to 0. So that condition is satisfied, and we have to show that the sequence is decreasing. So we have to show that 1 over the square root of n plus 1 is less than or equal to 1 over the square root of n for any n bigger than or equal to 1. So if this inequality is true, then that tells us that the square root of n is less than or equal to the square root of n plus 1 for all n. But you notice you can cancel the square roots. So this tells us that n is less than n plus 1, but the n's will cancel and we have 0 is less than 1, and that's a true statement. So by the alternating series test, the sum from 1 to infinity of minus 1 to the n over the square root of n converges. So now to determine if it's absolutely or conditionally convergent, we could take the absolute value of our a sub n term. So the sum from 1 to infinity of the absolute value of minus 1 to the n over the square root of n. So in absolute values, that minus 1 to the nth term will go away. So it's equal to the sum from 1 to infinity of 1 over the square root of n. So you can notice that this is a p series where p is equal to 1/2, and 1/2 is clearly less than 1. But you have to recall that the p series converges if p is bigger than 1, and here this is not the case. So by the p test, the sum from 1 to infinity of 1 over the square root of n diverges. So notice that when we use the absolute value in our series, it diverges, but we know that our original series converges, so we could say, so since the sum from 1 to infinity of 1 over the square root of n is divergent, then the sum from 1 to infinity of minus 1 to the n over the square root of n conditionally converges, and that is the result that we wanted. Thank you very much for watching.